Okay, today we're going to take apart our AND gate circuit here, and we're going to put together this circuit. So what's happening in this circuit here? Here's ground. There's 1, 2, 3, are there 4 switches here? Input A, input B, input C, and input D. I see we have 2 AND gates here. We have an inverter and we have an OR gate, and out of that we're going to wire an LED which goes back to ground. So let's do that on this circuit board. So first I would sort of plan how I'm going to do this, and it might be difficult for us to understand that how this actually relates to wiring up these chips. So what I want to do is I want to identify the chips that I have first. So I have an AND gate, a OR gate, and a NOT gate. So I can bring out those 3 chips, and then I have to remember what the pin out looks like on those chips, right? And if I remember correctly, these chips look like this. The pin out looks like this. It has pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And pin 14 goes to power and pin 7 goes to ground. And that's what my AND gate chip, that's what my AND gate chip looks like. And the OR gate looks the same, but inside this pin 1, 2, and 3, you actually have an AND gate wired. Well, I could just bring it up here. I can go AND gate pin out. So inside these AND gates, or inside this chip, you have 1, 2, 3, 4 AND gates. So no matter which of these pictures you look at, it's the same thing. Pin 1, 2, 3 is input, input, output. 4, 5, 6 is input, input, output of another AND gate. So you actually have 4 AND gates inside here. 1, 2, 3, 4. 1, 2, 3, 4. And if I looked at OR gate pin out, it's the same thing. 1, 2, 3, 4. So these are called quad input AND gate and OR gate. And so if I need to wire, which I do need to wire up 2 AND gates, I do not need 2 AND gate chips because there are 4 chips in each one. So I can just wire up AND gate that is in pin 1, 2, 3. And I can wire up AND gate that is in pin 4, 5, 6. And that's what I'm going to do. Then for the OR gate, I'm going to use pin 1, 2, 3. And for the NOT gate, I will show you the pin out for that. It's just in pin 1, out pin 2. Here we go. NOT gate pin out, in pin 1, out pin 2. There are 6 NOT gates in each of those chips, the 7404 chip. So I'm going to get my chips 7408, 7404, and 7432, and I'm going to wire them up. The pinouts still exist. Every one of these chips has to be held upright with the little notch like this, like I've shown you before, and ground is here and power is here. And these chips won't work unless they are connected to power and ground. So let's go ahead and wire this up then. There's a few ways to do that. What I would do is I would look first at this OR gate, and I would say that my my OR gate is going to have to, if I were to just sketch how I'm going to wire this, I would say my OR gate, pin 1, 2, 3, the output of my OR gate is going to go to that LED, and that's going to be wired to negative. And the inputs, one is going to be coming from pin 4, 5, 6 of my AND gate. So pin 6, remember there's also a pin 7 here, and in is 4 and 5, and the other one is going to be coming from pin 3, which is an output, and then in, and we have A, B, C, and D coming in there that are different inputs. Now out of one of these, you're going to have to also go to a NOT gate. So this one will have to go through a NOT gate into pin 1, out of pin 2 before it goes back in here as an input. So that's what I'm going to be doing, and I have to power, 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 ground, ground, ground each one. So let's do that. I'm going to hold my board so that it's upright for you. So there you go. The board is upright for you. And I need to be able to power this board. So I'm going to put a plus here and a minus here. And now it's powered all the way across should I plug it into a power supply. I'm going to put my AND chip at the front because I would like to, at the top because I would like to. And a reminder, that's what we're building. I'm going to put my AND chip at the top. I'm going to put my inverter in the middle. And I'm going to put my OR down at the bottom here because I see in my circuit that it goes OR and then out to an LED. I'm going to do that part because it's pretty easy. Now, reminder, the board is up. If you see A, B, C, D there, the chips are up. If you see the little notch facing up, the little notch is at the top of each of these chips. So now we have to remember that we have to power each of these chips. So we power it with pin 7 goes to ground, pin 14 goes to power. So there we go. We remember that these terminal strips are electrically connected across them. So I can take this out to ground way over here in column A, and then it's out of my circuit. It's out of the way. It's not in the prime real estate of a circuit. And same with this, I can bring this power over there. Now those are pretty small little jumpers. I should have a bunch of them made up, but I'll show you how to make them that small. It has to be so small. Looking at the insulation, it's just a tiny little thing. So I'm going to cut here, and then I'm going to strip there, and then I'm going to use my needle nose pliers. I'm going to bend a 90 degree, and I'm going to bend another 90 degree, and then I'm going to plug it in. And that's even too big. That one was too big. I'm going to unbend my 90 degree. I'm going to strip it a little bit further. I'm not strong like you, so I have to hold with needle nose pliers while I strip it. Then I'm going to bend that 90 degree again. And now it might be small enough to go from the very last column into positive. Still not. Still too big. You have to make these really small. Really tiny. In order to have these beautiful little power and ground, little staples I like to call them. And you can spend a Friday night making those. It's quite fun. Really tiny. Every one of these chips has to be powered, remember. If you don't power your chips, they simply don't work. It's like if you don't plug in your cell phone, or you don't put your cell phone on a battery. If you don't have a battery in your cell phone, it's simply not going to work. So it's the same thing here. Still, I'm making a few more of these little, now I'm making the little ground staples. They're little jumpers that are only going to go into ground. Tiny little jumpers for the other side. I'm making sure that it is in the same row as pin 7, because they're all electrically connected in that row. Took the whole insulation off that one. AND gate, pin 714, inverter, pin 714, OR gate, pin 714. Now they are all powered. We can power here, and the power goes across the board. So now I just have these powered chips, and I look at my circuit again, and it shows me that I want to come out of the OR gate into an LED. So here I am with an LED, and I remember that an LED has a flat side on it that'll go to negative. So I'm going to mount this LED here, and that is an output. I just like to do outputs in brown. And how do I know where that goes to on my pinout, or on my chip? I remember my pinout. My pinout says that pin 1, 2, 3 is in, out of an AND gate or an OR gate chip. So I'm going to put that in pin 1, 2, 3. Okay, pin 1, pin 2, pin 3. There we go. Sun's going down on us here. Pin 1, pin 2, pin 3. I have this already cut for a length way over here. Just going to modify that a little bit. These things take time. There we go. Pin 1, 2, 3. And there I have it mounted for an output, but it's not going to work because it has to go to ground, So there we go. I'm going to electrically connect that to ground. And you see that there's a space here. This is my LED, and this happened to be a short wire, so there's a space there, but that's okay because these terminal strips are electrically connected. So there we go. I've come out of this OR gate, and if you have to follow along, you can go check mark. I've done that to ground. Check mark. I've done that out of pin 3, which is the output of an OR gate. Now let's work on, I would work on the more simple one. The more simple one goes to this AND gate, the AND gate up here. So let's go to this simple one, and I'm going to wire to that AND gate. So an AND gate, this AND gate would be pin 1, 2, 3 is my first AND gate. So there's an input. well, I'm actually going to use the second AND gate. Pin 1, 2, 3, and 4, 5, 6 is also an AND gate. Okay, 4, 5, and then 6 would be the output from that AND gate. And the output from the AND gate, I want it to go into the input of this OR gate. So it has to go way down there. So I better make some wire that's going to go way down to the input of that OR gate. Around about like that. It takes some time to get your wires nice and the right length. When you use a needle nose pliers, then you get a straighter line than if you try to use your fingers, if you're strong enough to do that. So I'm going to go from the output. Pin 4, 5, 6 is in, out. So in, out. Out goes to the input of this OR gate. There it is, going to the input of that OR gate. Input of the OR gate. So output of the AND gate into the input of an OR gate right there. Right there. There. Output of the AND gate into the input of the OR gate. I probably shouldn't have stripped as much wire there. That's really not good technique. I'm going to do it again. Okay, so there we have it. It is going from the output of this AND gate, it's the second AND gate, into the input of the OR gate. So you would put a check mark on that. Output of the AND gate to the input of the OR gate. Check, you've got that one wired. Now let's look at this one. The other input of your AND gate, which you can make in whatever color you want. I'm gonna switch up the colors a little bit so that, you know what, I'm just gonna do black. So I'm gonna go into a NOT gate. So let's see here. This input of this OR gate goes to the output of a NOT gate. Looks like I can reach that absolutely perfectly with what I have made here. So here we go. I'm going to go to the input, to the output of a NOT gate. So remember the NOT gate has 6. There's 6 NOT gates in here. Pin 1, 2, 3, 4, 5, 6. Pin 8, 9, 10, 11, 12, 13. So it goes in, out, pin 1 and 2. So let's go into pin 2 because we want the output. We want this one. So I'm going to go out of pin 2 into the input of that OR gate. So there we go, out of pin 2 into the input of that OR gate. There we go. Absolutely beautiful. So that black wire there is this, and I would check mark that. So now I've done this, done this, done this, done this. I've done this and this. Now I'm going to go from the input of the AND gate, of the NOT gate here, and to the output of the first AND gate. So the output of the first AND gate is going to get inverted. The first AND gate is pin 1, 2, 3, in and out. So let's take the output of that AND gate and we invert it. The output is way over here, so I'm going to cut this wire. Go. That is on pin 3, in and out, pin 3, in and out. The output is getting inverted. The output is getting inverted. Now we need some inputs, and the inputs are going to be switch B and switch A. And there you have it. This is the entire operational circuit there, where you have switch A, B, C, D, which I can go and I can plug into positive if I want to give a 1, or I can plug into negative if I want to give a 0. And I can do all of the 16 combinations of that truth table, because there's 2 to the n, 2 to the 4, 16 combinations of this truth table. Right now I just gave it a 0, 1, 0, 1. And these 2 inputs went through an AND gate. The output of the AND gate went and got inverted, and it went into an OR gate. These 2 inputs go into an AND gate, output gets inverted, goes into an OR gate. These 2 inputs go into the AND gate, come out of the AND gate, and go into the other input of the OR gate. So these 2, those are these 2 inputs down here. Those are these 2 inputs down here that go into this AND gate, into the other input of this OR gate. All of that gets ORed. All of that gets ORed and out to the LED to tell you the output. Now, to determine whether your truth table is correct, you need to know what is a 0, 1, 0, 1. What do you expect out of this? Then I would do a Boolean expression for that. So I can make another video on the Boolean expression and how to make the truth table about this. But this is how you would wire up that circuit.